In this video, we're going to introduce the dot product. The dot product is a way of combining two vectors together. So imagine one vector called A and another vector called B. We're going to multiply them, and we'll see why multiplication is a reasonable analogy here. And the particular kind of multiplication we're going to use is called dot product. There are actually other variations that are out there, like a cross product, all have slightly different properties, but still have the same feel as multiplication. So, with a dot product, what we do is we have all the components of a vector and the components of the other vector in the multiplication, and then we talk about the product as being computed by the x components multiplied, and then we add the y components multiplied, and if we have three-dimensional vectors, we then multiply by the z components. Once we have those products, we simply add up all three of the ingredients. Notice that the result is not a vector. It is a real number or a scalar value. By the time we're done here, there's no square brackets, there's no commas. This equals some real value. Single real value. For that reason, the dot product is sometimes called the scalar product. From the definition, and with a little practice, it becomes straightforward to do this kind of multiplication. If we take 2, 4 dotted with a 3, 1 vector, what we're computing here is 2 times 3 plus the y components here are 4 and negative 1, so 4 times negative 1, and then just expanding. 6 minus 4 gives us 2. So the dot product of these two vectors is the number 2. If we go into 3 dimensions, exactly the same process. We take the x components, multiply them, and then we add the y components multiplied, here 7 and 2. And last but not least, the z components, if there are some, 4 and negative a half. And when we multiply that all out, we get minus 6 plus 14 minus 2 gives us 14 minus 8, which is 6. That might seem a little arbitrary at the moment, but we'll see applications where these values can be interpreted. There are some properties that come with the dot product, and again, these often have the flavor of regular multiplication or scalar multiplication. For example, the order doesn't matter. If you take two vectors and take the dot product, it doesn't matter which one you consider first. And again, you can see that in the formula. It didn't matter which values you put first in each individual product. If we have a dot product times, be careful here, a vector that's a sum of two other vectors, then we can distribute that multiplication inside the parentheses. If we take the 0 vector dotted with a, we get 0. Again, a lot of flavors of multiplication here. The only one that's particularly unique to the dot product and not necessarily the same as other products is this dot product with the same vector. If we take a dotted with itself, we get the magnitude of the vector A, and we get that magnitude squared. So it's similar to squaring a scalar value, but we also have to include this magnitude idea as well. Last but not least, if we have a scalar product as part of this, we can move the scalar value. So imagine we're multiplying things by 2. We can multiply the 2 by a vector, or multiply the vectors themselves first and multiply by 2 at the end, or scale the second vector. Any order is fine for mixing and matching those.